In Chapter 9, there are 5 different types of solids that we will find the surface area and volume of. We will be working with cubes, rectangular prisms, triangular prisms, cylinders, and cones. So today, our notes are going to focus on cubes, rectangular prisms, and triangular prisms. What you see here is the notes worksheet for surface area and volume that was included in your lesson tab. Now, that document is 2 pages. So again, today we're just going to work through notes on the first page, and next week we'll start notes on the second page. And what I'll be doing today is I'll be going back and forth between talking about a figure and how we calculate volume and surface area, and then going through an example with you. Now on the left side of this notes worksheet, you'll notice the first column says figure/net. What a net is it's a 2-dimensional representation of the 3D solid. So essentially what's happening is we're taking a box and we are unfolding it. And when we unfold it and lay it flat, that is what a net is. What a net does is it helps us to see all the different sides of the 3-dimensional figure, and we call those sides faces. So you can see here for the cube, it has 6 faces. 1, 2, 3, 4, 5, and 6. So 3-dimensionally, if you take a look at the figure on the right, we have 1, and then this one on the bottom 2, on the left 3, on the right 4, in the back 5, and up top 6, okay? And so again, when we take that cube or that box and unfold it, but keep the sides attached together, we would get the net that's shown on the left. So what I'd like to do now is talk about how we calculate surface area and volume. Surface area is just the area of all of the surfaces of a 3-dimensional solid added together. And volume is the amount of space that we can fit inside of the figure. All of our measurements for surface area are going to be in units squared. It's an area measurement. And all of our units for volume are going to be units cubed. Okay, so for surface area of a cube, here's what this formula means, okay? S represents a side length. A cube is a box that has all sides of equal length. So if one side is of length S, they all have a side of length S. And in the 3D figure, it looks like this, okay? And so what does this formula mean? Well, one of these faces would have an area of S squared. And since they're all the same size, I can just take the area of one of them and multiply it by the total number of sides, which is 6. And so that's where the 6S squared comes from. Side times side for the area of one of the faces times 6 because there are 6 of them. For the volume of a cube, what we're doing is we're saying, look, the area of that base layer times the height will give us the volume. And imagine if you place a really thin piece of paper that's the exact size of that base of the cube, and you keep stacking up pieces of paper until you fill the entire cube, you're going to stack them up for the full height of that cube. So the area of the base would be side times side, and then multiplying it by the height. Sometimes you might hear that the volume of a cube or of the rectangular prism below is length times width times height. And in general, for any prism, you can always find the volume by taking the area of the base times the height. So let's go through an example together right now where we find the volume of a cube. Here I have a cube that has a side length of 4 units. So if I'm finding the surface area, remember, all of the faces have the same area because the dimensions are all the same. So my surface area is 6 times the area of one of those squares. That means my surface area is 6 times 4 squared, because the area of one of these sides, like this one off to the left here, is 4 times 4, length times width, okay? So that's 6 times 16, which equals 96. So the surface area of this cube would be 96 square units. Then if I want to find the volume, remember we're taking the area of the base and we're multiplying it by the height. But since it's a cube, because all of my sides have the same length, the area of the base is just the side times itself, and the height has that same length. So my volume is 4 times 4 times 4, or 4 cubed. And that gives me an area of 64, a volume rather, of 64 cubed units. The second three-dimensional figure we are going to talk about is a rectangular prism. A prism is a three-dimensional figure that has two parallel faces called bases. So if you take a look here on our rectangular prism, we have parallel faces that we could consider bases. The base could be the side it's resting on. It may not be the side it's resting on. For this rectangular prism, we could consider the base to be this top rectangle and also the bottom one here that we can't see, but the longer rectangles could also be the bases, okay? So it doesn't matter as long as we're picking two sides that are parallel to each other. Now, if we jump ahead to this triangular prism, the only two sides that are parallel to each other are the two triangles. So those have to be the bases, okay, because they're the sides that are parallel. So in a prism, the bases are always parallel to each other. And in a rectangular prism, all of the faces are rectangles. So to calculate the surface area of a rectangular prism, what we're doing is we're adding up the area of all of the surfaces. And if we remember that opposite sides are congruent, we can shorten our work by calculating the face areas in pairs. And so that's what this is saying right here. So to demonstrate this in a minute, I'm going to go through an example with a figure that has numbers on it. And I think that'll help make things more clear for you, and I'll show you how opposite faces are congruent and how that can work for us as a shortcut. For the volume, remember, we're finding the area of that base layer and multiplying it by the height as we stack up thin layers throughout the entire height of the figure. In other words, we're taking length times width times height. Let's go through a calculation of volume and surface area for a rectangular prism. First, we're going to do calculations for surface area, all right? I'm going to use different colors to highlight different sides. So surface area is just the area of all the surfaces of the figure added up. This is a rectangular prism. The sides of this figure are all rectangles. So if you take a look, my front side here, I'm going to highlight it in this purplish blue color. Okay, this is a rectangle and it's a 10 by 4, right? The length is 10 and the width is 4. And the one in the back here that's dotted on these sides, okay, the side that's directly opposite is the same size, okay? Think about how a box is made, all right? Opposite sides are gonna be the same size, the same dimensions. So this one is also a 10 by 4. So I have two rectangles that have dimensions of 10 by 4. You see where those opposite faces are coming into play? All right, I'm going to switch to red. What if we take a look at the two sides of the box right here and right here? Those two sides are exactly the same. and they have dimensions of 4 by 3. 4 by 3. So now I have 2 more rectangles of dimension 4 by 3. And then finally, we'll switch to green here. We have to do the top and the bottom. So here's my top side of my box. Here's the bottom side of my box. Those 2 rectangles are the same dimensions. What are their dimensions? It's a 10 by 3. This side is 10, this side is 3. So I have 2 more rectangles of dimension 10 by 3. And so this is where that idea of computing the area of opposite faces in pairs can be a shortcut for us, okay? So to do my total surface area calculation, I have 2 rectangles that have a length of 10 and a width of 4. And remember, the area of a rectangle is length multiplied by width, okay? So that would be my front and the back side of my box. I'm going to add on to that the 2 rectangles that have dimensions of 4 by 3. Again, length times width, okay? And those are the 2 side faces, the left and the right side of my box. And then I'm going to add on the area of the 2 rectangles that have dimensions of 10 by 3. Again, length times width, and that was the top and the bottom of my box. So my surface area is going to be equal to 2 times 40 plus 2 times 12 plus 2 times 30. All right, and so we can finish up these calculations here. We're going to have 80 plus 24 plus 60, which gives me a total area of 164 inches squared for my surface area. Now if I want to find the volume of my box, again, the idea behind volume is it's the area of the base. Now any of these sides could be the base. I'm going to use the one it's resting on here, okay? It's the area of the base, and then we keep stacking up those thin layers for the height of the figure, which is 4. So volume is equal to area of your base times your height, or in this case, 10 times 3 times 4, which is 30 times 4, or 120 square inches. I'll show you using a different base, okay? Let's say we want to use this left side here. What I'm going to do is I'm going to erase this, get that out of there so it's not colored anymore. Okay, we'll get that out of there too. All right, let's say we want to use a different side for the base, one that it's not resting on. Let's use this side right here. Okay, what does that look like? I'll show you, we get the same answer. So if I'm using this side for my base, okay, volume is area of my base times the height. If that's my base, this is the height of the figure, okay, because I'm stacking up those bases for the entire height of the figure till I get to the other side. So the volume would equal the area of that base. It's a 4 by 3 times the height, which is 10. You hopefully can already see right here and right here, I'm still multiplying the same numbers together. Okay, and multiplication is commutative, so we can switch that order and still get the same answer. I'm still getting 120 cubic inches. Whoops, I did that wrong up here. That should be a 3 cubic inches, not squared. Okay? The third 3D shape we will be taking a look at today is called a triangular prism. It's called a triangular prism because the bases are triangles. Remember, in a prism, the bases are the 2 faces that are parallel to each other. In the picture over on the right, there's only 2 faces that are parallel. Those are triangles, so the shape is called a triangular prism. To figure out the surface area, again, we're calculating the sum of all of the surfaces. The two bases are the same. So we're adding together the area of 2 triangles plus the 3 rectangles. Now, the 2 triangles will always be the same size based on the definition of what a prism is. The 3 rectangles could be different, so we're not guaranteed that they are the same size. For the volume of a triangular prism, we're going to be taking, again, the area of the base times the height. Notice in the formula, they have 1/2 base times height times this big H. Big H, that's the height of the figure, and 1/2 base times height is the area of one of those triangles. So again, we're taking the area of the base and then layering it up for the entire height of the figure. Notice too that the figure is not resting on the base, and that's okay. It doesn't need to. All right, so let's go through some calculations. Here we have a triangular prism with some dimensions labeled. So if we're calculating the surface area, again, we have 2 triangles that are the same size, and then 3 rectangles that may or may not be the same size. So our surface area calculation, we're going to take the area of 2 triangles and add on 3 rectangles, okay? Let's take a look at this in parts. Okay, for the triangles, if we look at the one over here on the right side, it's got the dimensions that we need, all right? We need base times height. We're going to get the length of this base from this side over here, okay? Because that's a rectangle, opposite sides must be the same length. So that base has a length of 10 centimeters. The area of one of my triangles is 1/2 times 10 times the height, which is 8.3. This gives us an area for one of the triangles of 41.5 centimeters squared. 2 triangles then would have an area of 83 centimeters squared. So this number right here is important for our surface area. The 2 triangles have a total area of 83 square centimeters. Now we're going to add on all of our rectangles. There are 3 rectangles we need to find the area of for the surface area calculation. So I'm going to start with this one in front here, okay? We'll highlight that in purple. And this rectangle has a length of 14 and a width of 10. So I'm going to call that rectangle number 1, and it has an area equal to 10 times 14, or 140 square centimeters. We'll do the next one in green. We'll do the one on the back side here. So this one in the back there, okay, has a width of 10 and a length of 14. So for rectangle number 2, our area is equal to 10 by 14 again, or 140 centimeters. Now it so happens, 140 centimeters squared. It so happens in this triangular prism, all of those rectangles are the same, but that won't always happen. Okay, so you need to keep that in mind. Now we're going to do this one on the bottom that it's sitting on. That's going to be number 3. And that one has an area of 10 by 14 as well. Okay, The width is 10, the length is 14, so 140 centimeters squared. If we add these all together, that means all three rectangles, let's see here, 12, 40, 420 centimeters squared is the area of all rectangles put together. And so now we're going to add that to the area of the triangles. And so the surface area of that whole figure is equal to 503 square centimeters. For the volume, it's the area of the base times the height. Remember, in a triangular prism, the bases are triangles, even though it's not sitting on a triangle. Base does not mean that's the side it has to be resting on. Okay, in a triangular prism, the bases are the opposite faces that are the same size and are parallel. So that would be these two triangles. They're the only faces that are parallel to each other, okay? So I just need to take one of them, calculate the area, and multiply it by the height, because we're taking one of these bases and stacking it up for the entire height of the figure. So my volume is 1/2 the base of that triangle, which remember back up top we figured was 10, times the height, 8.3, times the height of that prism, which is 14. Multiplying those numbers together, we get a volume of 581 cubic centimeters. All right, and that's it for our lesson today. I want you guys to focus the rest of this week on finishing up your project for me that was assigned last week. Remember, you're doing a Venn diagram project based on certain characteristics of the quadrilaterals we've been learning about, and you're sorting the list of quadrilaterals I gave you into the Venn diagram according to the characteristics you chose. So if you have questions on that, please feel free to send me an email. That is your assignment for Friday. It was posted last week on Friday. I gave you a whole week to work on that, so don't forget about that. It's due by 11:59 p.m. on Friday. And that's it for today. I hope you guys have a great rest of the week and enjoy your weekend.